Hello guys, how are you today? So today I'll be explaining the physics diagnostic of term 2 week 1. Just again in advance, I'm not going to be doing the physics term 2 week 1 AMS quiz because it's the same as the term 1 week 11 AMS quiz. So let's start. Which of the following statements describing the safety measures while using radioactive materials are true? First thing, you have to make sure that the radioactive source is always pointing away from you and other people. You're not allowed to eat, okay? They should be locked up in a safe space, especially a lead box, because the lead box can stop alpha, beta, and it can minimize gamma. It's not safe to move a radioactive source with your hands, and they should not even be identified with your eyes. So there's only two correct answers. Question number 2. Consider two forces, each of magnitude 15 newtons, applied to twist a 2 centimeter cap as shown below. The moment of this couple. Very simply, to find the moment of a couple, we're gonna take force 1, like one force, 15 newton, and multiply it by the distance between the two forces, 2 centimeters. But do they need it in centimeters or meters? They need it in meters. Just 1 second until I get my calculator. Okay, and now to change from centimeters to meters, we are going to divide by 100. So 2 divided by 100 gives us 0.02. Multiplied by the 15 newtons, we are going to get 0.3 newton per meter. So very simply, our answer over here is 0.3 newton per meter. We move on to question number 3. Two downwards forces of respective magnitudes 15 newtons and x newtons are applied to a uniform plank of weight 20 newtons as shown below. They first need us to find the magnitude of x. Very simply, to find the magnitude of x, we know first of all, let's go up, that the plank is in equilibrium. What does equilibrium mean? Equilibrium means that the moments of clockwise is equal to the moments of counterclockwise. So if we go down and we are seeing they are asking us in part A for the magnitude of x newtons. We have 50 newtons pointing downwards, okay? And it is a clockwise rotation, okay? We also have x newtons pointing downwards and it's a counterclockwise rotation. So that means we have the moment clockwise and we have the moment counterclockwise. So we can very simply do moment clockwise is equal to the moment counterclockwise. So we know moment is equal to force times perpendicular distance. Okay, the first force is 15 newtons multiplied by 25 centimeters is equal to the second force x that we need to find multiplied by 40 centimeters. Then you bring 40 to the other side. It's gonna be 50 times 25 divided by 40. And you are gonna get that x is equal to 31.25. If you round it, it is almost 31 newtons. Now they need the upward force exerted by the fulcrum on the planks. Okay, here this is important. If you go up and we read the full sentence, we would have noticed that there is the weight of the plank, which is 20 newtons. So we don't have only these two forces acting. We have 50 newton, 31 newton, and 20 newton of weight acting. So very simply, we know that all force upwards are equal to all force downwards if it is in equilibrium. So it's going to be 50 plus 20 plus 31, which is 101 newtons. Now we move on to question number 4. They need the atomic number of this nuclide. Very simply, the number down is the atomic number, so it is 26. And the mass number is always the number up, so 54. So that is it for question number 4. Question number 5. Drag and drop to complete the following diagram to describe the penetrating power of different types of radioactive radiation. Very simply, you should know. Alpha is stopped by a piece of paper. Beta is stopped by a book. And as we said, gamma, it's partially stopped or it's minimized by the lead. You should know this. Question number 6. A radioactive source emits radiation into space where a downward electric force field is present. The source emits beta particles and gamma radiation, so there's no alpha particles. 3 detectors, A, B, and C, are used to detect radiation. Okay, very simply, what we need to know is that the alpha particles are positive, so they are more likely to go to the negative side. Beta particles are negative, so they are more likely to go to the positive side. Okay, so like the opposites attract each other. And then gamma doesn't have any charge, it's neutral, so it's gonna be a straight line. That means, very simply, A, because it only emits beta and gamma radiation. Beta particles have a negative charge, so that means they are more likely to go to the positive side, so it's supposed to go like this. Okay. Detector B, because we have also gamma radiation emitted, and gamma does not have a charge, it's gonna go in a straight line, so this is for gamma. And finally, we do not have alpha, so C will not detect anything. So A will detect beta, B will detect gamma, and C won't detect anything. So beta, gamma, and no radiation. We move on to question number 7. We need to balance this. In this reaction, very simply, what we need to do is make it an equation. Just make the arrow an equal. So if you're gonna consider the top part, it's gonna be 15 is equal to 15 plus A. That means A is 0. If you're gonna consider the down part, you're gonna get that 6 is equal to 7 plus Z. That means Z is negative 1. So 0 and then negative 1. Now we move on to question number 8. A person is pulling a box along a rough floor using a rope parallel to the ground. The tension in the rope is 25 newtons and the box moves through 2 meters at a constant speed. Okay? What does constant speed indicate? It indicates that the force of tension is equal to the force of friction, because there's no force that is like pulling it more than the other, since it's going at a constant speed. Okay, that means if we find the force of tension, then very simply we will, if we find the work of tension, then very simply we will find the work of the frictional forces, but it has to be in the opposite direction. The work of tension, okay, is gonna be the force, 25 newtons, multiplied by the distance, which is 2 meters. So it is 50 newton per meter, or 50 joules, okay? One thing we should know is that frictional forces are resistive. So since they are resistive, we are gonna put negative. So it's gonna be negative 50 joules. So very simply for this question, because it is at a constant speed, tension in the rope is equal to frictional forces. Find the work of tension, then add a minus because frictional forces are resistive, and like that you get the work done by frictional forces. Question number 9. A box of 15 kg is lowered through 2.5 meters. Use G equals 10 meter per second squared. They need the work done by gravity. Remember, the work done by gravity, if it goes down, it is positive. If it goes up, it is negative. Here, it is lowered. If it's being lowered, that means it is going down. That means the work done by gravity is going to be positive, first of all. Next thing, we know always the equation for the work done by gravity is mgh. M is 15, G is 10, and H is 2.5. So 15 times 10 times 2.5 is 375 joules. So the work done by gravity is 375 joules. Question number 10. Determine the type of electromagnetic radiation being used in each appliance. So very simply, if we are talking about night vision, that means we are talking about infrared radiation. Always remember, infrared radiation gives you night vision. Why exactly? It's because infrared radiation is also emitted by bodies, like particles of the body. So for animals and humans. So that's why, like, when you're using the night vision, the infrared radiation is gonna be detected. So it's gonna show a red color, if you know, so you can see like the object moving, because as it's moving, it's also releasing infrared radiation. So this is how the night vision works. Food heater, very simply a microwave, it will use microwaves. Medical imaging is literally an X-ray, so it's gonna use an X-ray. And broadcasting towers, it is like a radio, so it's gonna be using radio waves. Question number 11. They need the mechanical energy. We have mechanical energy is equal to kinetic energy plus gravitational potential energy. Okay, the equation for kinetic energy is 1/2 times the mass times velocity squared plus GPE, its equation is mgh. So if you do it on the calculator, you have the mass over here, which is 1.2 kg, the height, which is 2 meters, the velocity, which is 5 meters per second squared, and then you have g. So if you're gonna do it on the calculator, it's gonna be 1/2 times the mass, which is 1.2, times 5 squared. You're gonna get 15. Add it to what? To mgh. So 1.2, the mass, times the height, 2 times the g, 10. And we are gonna get 39 joules. Question number 12. The energy required to turn 1 kilogram of a substance from a solid into liquid. Solid to liquid is melting usually, but in physics we are gonna call it the specific latent heat of fusion. From liquid to gas is considered boiling, but in physics we are gonna call it the specific latent heat of vaporization. Question number 13. The absolute temperature of a gas at 150 degrees Celsius. Very simply, to find the absolute temperature of something, you're gonna add 273 to it. So 150 plus 273 is then 423 Kelvin. So 423 Kelvin. Question number 14. Use Planck's constant is this. Okay, they need the energy carried by a photon. If you remember, the energy carried by a photon, which we're gonna call it E, is equal to Planck's constant h times the frequency. We are given his constant and we are given the frequency. So very simply, we can find the energy E. It's gonna be 1.2 times 10 to the power of 15 times 6.6 times 10 to the power of negative 34. And like this, we get 7.92 times 10 to the power of negative 19. Check over here, we have 7.9 times 10 to the power of negative 19. So that is it for question number 14. Question number 15. A sample of 70 grams of steel, we have the specific heat capacity being 385 joules per kg times Kelvin, is heated from 20 degrees Celsius to 80 degrees Celsius. The quantity of heat needed to raise the temperature of this sample. Quantity of heat, meaning Q, is equal to, we have the mass, but we have to change it to kilograms. So 70 grams into kilograms divided by 1,000, you are gonna get 0.07. We have the mass. We have the specific heat capacity, which is C. We also have the change in temperature, which is 80 minus 20, which is 60. So delta T equals 60. So very simply, Q equals MC delta T. M is 0.07 times C, which is 385, times delta T, which is 60. Doing it, 0.07 times 385 times 60, we are gonna get 1617. But look, pay attention, we have the specific heat capacity in joules. So to change it from joules to kilojoules, we just need to divide by 1,000, and we are gonna get then 1.617 kilojoules. So 1.617 kilojoules. Question number 16. Below is the temperature time graph of a sample of matter being heated. They need the phase change. Where does the phase change occur? It occurs between the time interval 2 minutes and 8 minutes. So here I think they did a mistake in labeling it. It's supposed to be 2 minutes, not 2 seconds. But anyways, it is 2 minutes and 8 minutes. This is the phase change. Actually, let me explain more. Phase change occurs only when it is flat. So what's happening in this over here? The kinetic energy is increasing. That means the temperature is increasing, since kinetic energy and temperature are directly proportional. Okay? But the potential energy stays the same. That means we have only one state. So let's say solid. When we move to the next one, because it is flat, it is a flat plateau. That means the potential energy is increasing. Kinetic energy stays the same, temperature stays the same, and what's happening is that the solid is turning into a liquid. Then when we move to the next one over here, it's continuing the same process. So it's gonna be the same as this one, where the kinetic energy increases, temperature increases, potential energy stays the same, and it's only one state, which is liquid. So it's a phase change. It's two states, two like phases of matter. So solid and liquid together in the same time, which is between 2 and 8 minutes. Now we move on to question number 17. They're asking us, is energy transferred if a book is resting on a table? If it is resting, it's not moving, so there's no energy transfer. A bucket is lifted upward at a constant speed. There is an energy transfer. Why? Because it is moving. As long as there is a motion, then there is an energy transfer. A rock travels uniformly through open space. If you hear the word uniformly, that means there is no energy transfer. And a ball is in free fall, it's moving downward, so yes, there is energy transfer. The only conditions where there is no energy transfer is only if it is resting, there's no motion, or if it's moving uniformly. Okay, now the final question, they need the power. Okay, we have the mass in kg. We can find the height, 12 floors, each is 3.2 meters. And then we have G and we have 10 seconds. Very simply, we know power is equal to work divided by the time. If we find the work, we can divide it by the time to get the power. We have mgh. Okay? This is the equation we're gonna use. Why? Because we have the mass given, we can find the height, and we have G. So mgh. We can find the work. Okay? So the mass is 320 kg times the G, which is 10, times the H, which is 12 floors, multiplied the height of each floor, so times 3.2. 320 times 10 times 12 times 3.2. If you do it on the calculator, you are gonna get a big number, which is almost 122,880. Okay? Is this what we need? No, it's not what we need. Instead, we need the work. So this is our work. Us, we need to find the power. So we found the work. We need the power. We are given the time. So work divided by time. This divided by 120 seconds. We are then gonna get a power of 1024 watts. So the answer over here is 1024 watts. I did not submit this quiz before. Let's submit, and hopefully we do not have any mistakes. Alright, great. We did not get any mistakes. I hope you guys enjoyed and have a wonderful day.